Neto here, and I'm going to do a quick overview of speed, velocity, and acceleration. These are three terms you guys should be becoming very familiar with, especially as you've played with the labs and thinking about how these three terms play in relationship to one another, play into relationship with Newton's laws, play into relationship with your water park slide. So that's the big overview. But I wanted to give you guys some concrete definitions and ways to graph these three terms to help kind of solidify what these terms mean. Please feel free to pause the video at any point and take notes, either in your digital notebook directly or on a whiteboard or piece of paper, and then take a photo of those notes and upload them to your digital notebook. So our first term is speed, and this is a term, again, you guys should be very familiar with, the most familiar with out of the three, because you see speed on a regular basis with whenever you're driving. So any of the speed limit signs that you see on the side of the road basically determines how fast your car should be going over a certain time. And if you wanted to get from Windsor to San Francisco in an hour, you have to be going at about 78 miles per hour because it's about 78 miles to San Francisco. So to get that distance over an hour, you would want to be going that distance over the hour. Make sure that whenever you are calculating speed that you are attaching the units along with it. So whether that's centimeters over seconds, miles over hours, kilometers over calendar days, you want to make sure you have a unit of distance and a unit of time, and you're going to divide those things in order to get the speed. A really great tip when trying to calculate the speed with your labs is use a reference point. That's a stationary object like a tree that you can use to help figure out the speed, direction, and or position. So this is actually how you would graph speed if you were to be calculating it several points over lab entries, like collecting data. And I want you to note that it is a straight line that is going tilted upward. It could be tilted upward or it could be tilted downwards. Either way, that would represent either a fast speed or a slow speed. Velocity is actually a term that you guys should become familiar with. Again, or just remember this one because it was a term that a lot of you guys missed on the science assessment number 1, and so it may show up again on science assessment 2. But velocity is simply speed, which is direction over time, with a direction in place. So, for example, my velocity when I drive to work is an average of 60 miles per hour south, and my velocity when I drive home is average of 60 miles per hour north. So again, we have this distance over time with this new variable of direction attached. Our last term is acceleration, and in science, acceleration can be the increase in speed or a decrease in speed or the change in the direction. So acceleration is the final velocity or final speed minus the initial velocity, initial speed, over time. So if we were to be looking at on that top bar of our division bar, distance over time minus distance over time, and then divide the entire thing by time, That's why we get a change of distance over time or a change of speed um, with time squared because we have this time going twice. So the change in velocity is over time. The best way I can explain this, again, looking at cars, a lot of times people will buy cars that can accelerate 0 to 60 in 3.5 seconds, as an example. So, how fast can I get to a quick speed? How fast can I go from not moving to really, really fast? And then I might stay at that speed at 100 miles per hour. But if I can get from 0 to 100 miles per hour in, let's say, 10 seconds, that's really fast. And so that's what we're looking at when we're looking at acceleration. So the graph what this shows, acceleration will have a curved line because you'll see that as you are accelerating, you're actually moving at a faster distance over a shorter amount of time. So that steeper curve is looking at a faster acceleration. So here are a couple of graphs to remember. And when I'm using velocity and speed, I want you to remember I'm using these a little interchangeably because the only difference is between the two is the direction. So a positive velocity is going to be curving up or a straight line up. A negative velocity is a straight line down. Not moving, this is interesting when we are not changing a distance, so meaning that we're staying in the exact same position for a very long time, that means we're not moving. There's no speed. We're not going in any kind of, like, we're not moving 5 feet. We're not moving 10 feet. We're actually staying at the same distance. So a straight line across is actually showing that we're not moving. A positive acceleration is that curve, and you should be able to see how fast something accelerates by the steepness of that curve. Same with the decrease of acceleration by the steepness of the curve will actually determine the quickness of the acceleration or deceleration. So hopefully that kind of clarifies a few of these terms. It adds on the mapping out of these terms. If you have any further questions, feel free to ask me or look up some additional YouTube videos to kind of help further clarify. But the next thing I want you guys to do is actually practice using these equations in some word problems. So please, if you want to go and head over to the word problem station, that'll kind of give you a better idea of if you understand it or not. Okay? Neto out.